Hi, my name is Nate Wisen, and this project demonstrates a serverless AI-powered document processing pipeline built on the AWS system using Amazon Bedrock. The goal of the project was to automatically analyze unstructured text documents, things like reports or notes, without managing servers. When a user uploads a document, the system automatically processes it using an AI model and stores the results for later use. So let's take a look at why I want to pick this and kind of the problem behind this. In consulting and enterprise environments, teams often deal with large amounts of unstructured text, and manually reviewing those documents is slow and inefficient. In my own life, as a consultant in the past, I've had to do this for hours upon hours, and it's very inefficient. So I wanted to build something that could ingest documents in real time, summarize or analyze them automatically, and then store both the results and the metadata in a scalable way using only serverless services. So let's take a look at the architecture and how we kind of jumped into it. So here's the architecture, at least the basics of it. As you can see, a user uploads a document into a static S3 bucket or static website. That then goes into an upload bucket, which hits a Lambda function, which hits the backend AI support, which is in this case Claude 3 Haiku. And then that goes into a DynamoDB table as well as an S3 process folder. So the purpose of this is to analyze large amounts of unstructured text via AI. The project overview is receiving documents via S3 uploads, triggering a Lambda function to orchestrate processing, invoking Claude 3 Haiku on Amazon Bedrock for summarization and classification, and then storing the process output in S3 and metadata in DynamoDB. And then finally providing the option to display results through a front end. However, I chose not to do that because that doesn't really make sense. So, jumping into it, what was the technology used in the system? The technology was a cobbled together effort pulling in Amazon DynamoDB, Claude 3 Haiku, and again, that's the backend Anthropic AI system, as well as Lambda using Python 3.12 or 1.2, depending on how you say it, Amazon Bedrock, again, that's Claude, Amazon DynamoDB. There's an API gateway in the mix. There were many IAM roles and policies, as well as throughout the process, I used CloudWatch logs to go back and forth and determine if the code I was writing for this Lambda function was actually making sense and if it was executing, which, spoilers, it was not for hours. So there was about 7 hours of debugging that finally got, in the end, the system working. And if it's working well, which it should be, I'll show you a live demonstration at the end of this. So moving through this, here's the workflow again. Basically what happens, a user uploads a text file to an Amazon S3 bucket. That upload triggers an AWS Lambda function written in Python. The Lambda function reads the document and sends the text to Amazon Bedrock using the Claude 3 Haiku model, which you see here in the model. The AI-generated output is then saved back to an S3 bucket. The metadata about the document, such as the file name, the timestamp, and the snippet, is stored in a DynamoDB, and you see that represented here. Everything is event-driven and fully serverless. So let's take a look at some of these steps of how I did it. The first step was creating the S3 bucket setup and the DynamoDB table creation. First, I created an S3 bucket. You can see the name of it there. You can see the region that I picked. It was in the Ohio region. Next, I created two folders in the bucket. And you can see on the screen, they were named incoming and processed. And you'll see once we get deeper into the flow, the incoming, that's where I upload a document, and the process is after it's gone through the generative AI system, that's where it spits out the process outputs. The next step was, still in step one, was I uploaded a test document to the incoming folder. In this case, I named it test file 3, and you can see a screenshot is here. This was just to make sure that the bucket was working, that it was functional. And then after I uploaded this, I deleted this file, although you'll see it again because I used it many times to re-upload it to test that my Lambda function code was working correctly. So after it was uploaded, we move on to the next step. And the next step was that continuation of the bucket setup. Here I needed to create a DynamoDB table named document metadata, and I created it with a partition key of file name, and that was a string. This table stores metadata for each process document, including the file name, timestamp, and a snippet of the process data. Why is this important? In case I have duplicates, or in case I accidentally duplicates by accidentally uploading the same document multiple times, I can come in here and look at the file's name, the timestamp, and the snippet to differentiate between those two. And then over here on the right side of the screen, you see the general info for the DynamoDB table of document metadata. So again, so far this is all things we've learned in the class. There's nothing special yet. Again, creating S3 buckets, and then going in to the DynamoDB table and creating some DynamoDB tables. Then step 2, Lambda function setup. So next I created a Lambda function. Here I went into the function, and again, this is not anything special from what we learned in class. We will get into some special factors that I had to apply to this, but at this moment, there was nothing that was too special. So created a Lambda function, added a trigger, made sure my S3 bucket was attached to this Lambda function so that they could speak to each other. And then it came into attaching the IAM roles. And actually, before we get into this, let me speak to the difficulties in this code. This is a Python-based code because, again, I chose Python 3.12 or 3.12, depending on how you say it, to write my code in. And I had hours of debugging issues. Specifically, some of the challenges faced, probably the biggest challenge in this project was getting Amazon Bedrock and Claude 3 to work correctly. In general, Claude 3 only supports the messages API, not the older prompt-based format. And it also requires a specific Bedrock API version and an interface profile. The error messages, tough words. The error messages were often vague, so debugging took several hours, as I mentioned. Again, by no means easy. I also ran into IAM permission issues and DynamoDB validation errors, which required carefully aligning table schemas, partition keys, and Lambda permissions. That took, again, hours and hours. So what you see, is the finished product. So the Lambda function, dropped in the code, did my S3 writes. So I had to do multiple IAM roles for permissions so that the S3 buckets would work within Lambda, Lambda would talk to DynamoDB, and the whole system, structured as it was, had permission to talk to each different layer or step in the process. So here you see on the screen, I had to write permissions for the S3 read-write access. Then I had to do permissions for the DynamoDB pull it to me access for document metadata so that Dynamo could pull documents to itself. And then I had to do the same thing for Bedrock, invoking permissions so that Claude model could work with the rest of the system. Then I updated both the Lambda timeout and the memory fields. The reason I did this, I had an error when I was working within Lambda when I was trying to talk to Claude. And my CloudWatch text documents kept coming back with errors. And the error was that Claude kept timing out too early, or the system was timing out before Claude had time to think. Because again, it's an AI-based system. It takes a little bit longer to process than the system is normally used to. So instead of the 3-second timeout, I actually increased it to the 30 seconds you see circled here on the screen. And for memory, although maybe not necessary, I pushed it up to 256 megabytes, just so that that's something that we could, so that the system had more time for the AI backend to think. Once that was done, I made sure that my Lambda code was updated. I had to constantly be updating the Lambda code every time I added a different aspect in this pipeline. I had to go back to the code and make sure it was talking. So again, this process took hours and hours. But here you see a example of the finished code. Obviously, if I showed you the entire 100 and something lines of code, it wouldn't fit here. So this is just a representation. Finally, after this all was in place, it was time to start testing it. And by testing it, I uploaded text file to the S3 bucket. I then observed my CloudWatch logs to make sure there's successful execution, looking for things like reading of the S3. I want to make sure all the characters in that text file are being identified, that they're being extracted, and that the output is saved to my Wyzen doc upload folder. Once that was done, I then went to my S3 bucket, made sure that there was something actually in the process folder, and then I went to the DynamoDB table and made sure in that document metadata table there was actually items there that were representative of what I'd actually uploaded. So that's how I verified the path. So we'll wait to wrap up. Actually, we'll wrap up here and then I'll take you through a live version. So what we did from start to finish, we identified an AI-enabled pipeline where a user could upload a document and the AI backend could scrub through it and do some examination on the contents of that document. And after it was done scrubbing the backend of that document, it would push that content into an S3 bucket and the Dynamo bucket as well. So let's take a look at how that actually works. So here we are in my general purpose buckets, my S3. I click in one, I go to my incoming, I go to upload, add files, I pull the document I know has text in it, and I upload it. Once it's successfully loaded, I go to my CloudWatch functions, pardon me, wrong thing, go to CloudWatch, log management, this is the one I'm using today. I always like to refresh it even though it doesn't need it. Go to my latest, scroll through, everything looks in order, there's no errors. Now I want to verify, I go to my S3 buckets again, this time I go to processed. Yep, test3 file is there, that's excellent. And now we go to my DynamoDB, go to my tables, go to explore table. Yep, and right here we have incoming text3, which I just uploaded, and it shows me all the information I need. So there we go, a working model from start to finish. I uploaded a document, the AI backend scrubbed it, and here I'm able to see the out processing of what it did. So that's how it works in real